day, learners. Once again, we are back today. We are still on first principle calculus. First principle. So remember, in the previous videos, I've introduced first calculus, first principle, and where the formula comes from. Remember, we've said that first principle says the first derivative is equal to limit sh approaches 0 of f of x plus h minus f of x all over h. We've did two examples, so now we continue doing other examples. Let's say they are saying find the derivative of, you are given f of x is equal to 3 over x. They are saying differentiate this f of x from first principle. That means that you must find the first derivative of f of x using first principle. Remember, the requirement for first principle, we must have what? F of x. Do we have f of x? Yes. What is the second requirement? The second requirement is that we must have what? F of x plus h. What is our f of x plus h in this case? Our f of x plus h will be what? Where we see x, we put x plus h. That means our f of x plus h will be 3 over x plus h. So since we have our f of x and our f of x plus h, then we can now use our formula. We are going to say f prime x will be the limit as h approaches 0, f of x plus h minus f of x all over h. Then we are going to say, remember, we continue writing the limit as h approaches 0 until we substitute 0 where we see our h. But then when in the starting, we can't substitute 0 where we see our h, since h is our denominator. That means we are going to have an undefined solution in that case. So we start by factorizing, simplifying, and cancelling until we see that we can't simplify further or we can't factorize further. Then that's when we do what? We substitute 0 where we see our h. So what is our f of x plus h? Is 3 over x plus h minus what is our f of x? 3 over x all over what? H. The limit as h approaches 0. For us to be able to solve this, let's solve the numerator. Remember, in the numerator we have 3 over x plus h minus 3 over x. So in this case, we want to make the denominator to be the same. So when making the denominator to be the same, that means we must multiply by the denominator x plus h over x plus h in this side. Then in the other side, let me erase here. In the other side, we are going to multiply by what? X over x. And remember, when multiplying by this and this, it's the same thing. There's nothing that changes here because x plus h over x plus h is what? Is equal to 1. That means there are no changes here. Then when we multiply, we'll have in this side is 3x over x into x plus h. Then minus, what is 3? 3 multiplied by x plus h is 3x plus 3h. Put it in brackets to show that this negative affects this whole thing. Then the denominator is x plus h. So since now we have the same denominator, that means we can write this thing all over the same denominator. Then we come again here. What is our denominator? X into x plus h. So now we put our numerator. In our numerator, what do we have? We have 3x. Remember, this negative affects everything. That means it's minus 3x minus 3h. Divide. Don't forget the division sign. Divide by h. So now let's continue. We continue writing the limit as h approaches 0. 3x cancels negative 3x. Then we are left with what? Negative 3h over. The denominator, when we simplify, is x squared plus xh. Then what happens here? When we change the division sign, this sign, when we change this division sign, to multiplication sign, what do? We are going to write h as 1 over h. Then what happens here? We can see that negative 3h over x squared plus xh multiplied by 1 over h. This h will cancel this h. Then we are left with what? We are left with limit as h approaches 0 of, since well this h cancels this h, is negative 3 over x squared plus xh multiplied by 1, which is still the same thing. So now can we simplify further? No. Even if we simplify, there's nothing that is going to cancel. Then now we can substitute 0 where we see our h. Then remember, when we substitute 0 where we see our h, we don't write the limit anymore. We are going to say negative 3 over x squared plus x into 0, which is what? Negative 3 over x squared plus x multiplied by 0 is what? Is 0. That means your solution is what? Negative 3 over x squared. So let's do another example. Let's say you are given that f of x is equal to x cubed. If you are given that f of x is equal to x cubed and they say differentiate this equation from first principle, what are you going to do? The requirement is that you must have f of x and your f of x plus h. So let's calculate our f of x plus h. Our f of x plus h, that means you are going to write what? X plus h, where we see our x. Remember, x plus h, this cubed affects your x. So in this case, our x is what? X plus h. That means it's x plus h cubed. And remember, x plus h cubed is what? Is x plus h into x plus h into x plus h. Then when we simplify, we will have what? X squared plus 2xh plus h squared multiplied by what? X plus h. Then we simplify again, we'll have what? X cubed multiplied by what? Plus x squared h plus 2x squared h plus what? Plus 2xh squared plus xh squared plus what? Plus h cubed. That is what we have. This is what? This is our f of x plus h. Do we have like terms? Yes. We have x cubed, only one x cubed. X squared h plus 2x squared h is what? Is plus 3x squared h. Then we are done here. 2xh squared plus xh squared is what? Is plus 3xh squared. Then plus h cubed. This is our what? F of x plus h. So can we now use the formula of first principle? Yes. What does the formula say? F prime x will be what? The limit as h approaches 0 of f of x plus h minus f of x all over h. What is our f of x plus h? Our f of x plus h is x cubed plus 3x squared h plus 3xh squared plus h cubed minus what is our f of x? X cubed divided by what? H. Remember, I said you must always write the limit. Okay, so we continue. Remember, I said always when solving from first principle, your f of x will be cancelled by something from f of x plus h. In this case, our f of x is what? Is x cubed. That means x cubed must be cancelled by x cubed from f of x plus h. And we can see that this negative x cubed is positive x cubed. They cancel each other. Now we are left with what? The limit as h approaches 0 of what? 3x squared h plus 3xh squared plus h cubed all over h. Remember, I said in this case, where you have to take out your common factor after simplifying, you always take up a common factor of what? Of a single h. The limit as h approaches 0, we are always taking out the common factor of a single h. We are not taking out the highest common factor, remember, in limits. In this case, limits from first principle. But in any other case, you must take out the highest common factor when solving for x. But then here we are not solving for x, we are differentiating from first principle. That means you are taking out a common factor of a single h in the numerators. Then we are left with what? 3x squared plus 3h xh plus h squared all over h. Then this h cancels this h. We are left with what? The limit as h approaches 0 of what? Of 3x squared plus 3xh plus h squared. Can we simplify further? No, we are done. Then we substitute what? 0 where we see our h. Since, well, now if we substitute 0, we are not going to get an undefined solution. So now it's going to be 3x squared plus 3x into 0 plus 0 squared. What is this? 3x into 0 is 0. 0 squared is 0. That means we are left with what? 3x squared, which is our answer. Okay, thank you. Now, let me check. I think we are done for the session. Thank you once again. Don't forget to like, comment, and subscribe.